All right, so I was able to figure out a solution to exercise 4 on Joy of X lesson 8. At least a partial solution. I can't get it exactly how they have it in the video, but I can. Well, I can actually get it pretty close, I think. Let me actually use curl noise. Yeah, okay, I can basically get it how they have it. So, so this part right here is exactly the same as before, except I'm using curl noise instead of noise. We can show the difference here. So that's with noise, and then this is with curl noise. They're just two different algorithms for creating noise. Not anything too crazy there. Now let's look at this. So actually, I'll start from scratch and explain each step. Oops. Yeah. So this is what we would have basically. This is what we have from before. Although my scale is animated, so I'm gonna actually just really quickly remove keyframe and remove, and we'll dial in. Let's try like 0.9 all across the board. I think will be good for me. Yeah, looks good. So the exercise says, can you make sept noise blocky noise? Hint, when we did quantizing in an earlier lesson, we took our distance d and trunked it to reduce its precision. Here you want to copy at p to a temporary vector position, quantize it, and feed that result to the noise. So what are we thinking here? So it could be tempting to do this. But the problem with that is we're actually changing our position of our points. If we go to our points here, we actually have a bunch of them stacked up on each other. That's not exactly what I want to do. But what I do want to do is I want to truncate the position, but I don't actually want to change the position. So what we can do is we can say, hey, let's make a new vector. We'll call it pos for now. Just stands for position. And we will say pos is equal to at p. So basically what I'm doing is I'm creating a vector called position, and I am temporarily assigning each point's position to that vector. I'm essentially just copying that information over. And if I can show this, because if we create a vector attribute, we can see here's our new vector, and it lines up exactly with our values of our position vector. See, here's our position numbers, and notice they're the exact same. So now what we're going to do is we're going to say, hey, let's go ahead and truncate that. Now what did that do? Well, in order to see what it did, I have to put this afterwards. So let's start with that. Alright, so let's see here. Minus 5, 0, minus 5. Minus 5, 0, minus 5. So far, so good. Minus 4, minus 4.79592. 0, minus 5. Whoa, wait, that's not the same. Minus 4, 0, and minus 5? That's weird. Minus 4.59184, 0, and minus 5. Same thing. Suspicious. This truncate function is changing these numbers. It's basically taking all of the ones that have decimals, and it's saying, I'm going to chop all that stuff off. Right? So notice how this minus 2.95918, that is being turned into negative 2. So what that ends up doing is we have a whole bunch of points that used to have different positions, right? They have different positions here. Look, they all have different x positions. And now those same points have the same values for that position vector. But remember, I'm actually not using this to affect the point's position. I actually just want to feed this into the noise function. So I'm going to take my @p here, and I'm not going to feed it the position. I want to feed it this new vector that I made. And voila, we have blocky noise. Why does this work? Well, because see all these points here? All of these points that are in these blocks all have the same values for that vector. And so when we feed it into our curl noise function, it's going to give the same result, right? It's like basically saying, it's like if you have like a whole bunch of people in line ordering like food at like a taco truck, it's like 10 people in a row all ordered carne asada, right? And the same exact amount. They all ordered 2 carne asada tacos. And so it's like, think of it as like all of these points in here, they all ordered the same carne asada tacos. These points over here, they all decided to order chicken tacos. Right? Now, that's why they all look the same. Now, if we didn't do this, right? If we changed it to @p, what that does, why it looks so random, is because every single one of these people is ordering a different taco type. Literally, almost every single one. I mean, there's a few carne asada over here and here and here, but for the most part, it's pretty random. But when I feed it this truncated vector, now all of a sudden people are kind of ordering the same thing. So that's kind of how you get this blocky type effect going. I know it's a weird analogy, but it's kind of the way that it works in my mind, and hopefully it'll trigger the same understanding or the same light bulb or whatever. But yeah, so that's basically the key here. Now this attribute, you actually don't need this for the code to run, and I would actually recommend getting rid of it to save memory, especially if you're using the effect on a large amount of geometry. Leaving those attributes on your geometry can get really expensive, but the idea is when you're learning, it's really helpful to do that sort of thing so that you can see what's happening to the numbers. You notice, like, it's kind of hard just by looking at this to see what's going on here, but when I have that back in, now all of a sudden we can start to see the relationship between the numbers. And that's really, like, for me, that's like the biggest key. Once I started doing stuff like this, I started really understanding VxEL a lot better. So if something's happening behind the scenes and you're not sure what's going on, I think almost the first step I would almost always take is writing it to an attribute on your geometry so that you can start to kind of, really compare the numbers and see how it's changing it. Because let's say you're doing this for the first time and you're like, well, I have a function here and it's doing something to this position vector. It's definitely doing something to it, but I don't know what it is. And so that's where you can start to use these techniques that I have to kind of teach yourself, basically. It's a really powerful tool. So anyway, that's how you make stepped noise, and hope this was helpful. And I'll continue providing educational visual effects content throughout the upcoming weeks and months.